Okay, I'm just going to be proving the formula for the surface area of a sphere. So this is a hemisphere, but it's easier to work with for now. So it has a radius of r, so let's draw that in. And let's also draw an angle theta. Okay. Now, if we draw a line straight down, like that, and another line straight across, in a right angle triangle, this length will be the cosine of theta times r, and that will also be equal to this length. Right? So this blue length is cosine of theta r. Now, what we're going to be doing basically is timesing this by 2 pi to get a circumference, and then timesing it by a tiny thickness, right? But we need to describe that thickness in terms of delta theta. Here's delta theta, right? And obviously we're going to be integrating, so it'll go to 0. And we need to just describe this thickness here. Now that's going to be delta theta out of 2 pi radians multiplied by 2 pi r, right? The total circumference. And those cancel, so we get delta theta r. And we're actually ready to set up our integral now. So we're going to have, it's a pretty bad integral symbol, let's redo that. I'm going to have the integral from negative pi over 2, right? If you're thinking about what we want to do, we're going to be going down to negative pi over 2, or negative 90 in degrees, up to pi over 2, right? 90 degrees up. Negative pi over 2 pi over 2. You might be thinking why I didn't write that as 3 pi over 2. You'll see in a sec, because it'll just make more sense like that. And we're going to be integrating 2 pi times the cosine of theta r, right? Our mini radiuses up the sphere. And we're going to be timesing that by delta theta r. There's lots of things we can do with this. The first one is we can, instead of doing negative pi over 2 to pi over 2, since it's the negative and the positive side, and this is a symmetrical graph, we can just double it. We can go 0 to pi over 2 and double it. We can also pull out a 2 pi and 2 r's, right? So r and r, that's 4 pi r squared if you just do the multiplication, times the integral from 0, let's do some more room actually, the integral from 0 to pi over 2 of cosine of theta, and really this should be a d theta now because we've made it infinitely small, d theta. And integral of cosine is sine, so we have 4 pi r squared sine of, let's plug in our pi over 2, pi over 2. Sine of pi over 2, or sine of 90, is 1, so our finished formula is, let's put it at the top here, 4